Welcome everyone. My name is Harneet and I'm from the marketing team at Ecopia AI. We're excited to host this live event on mapping a changing world with geospatial imagery and AI in partnerships with our friends at Airbus. It is interesting to note that we have participants from over 65 countries attending this webinar live. That's a lot of countries to count. This is an important topic we're talking about today. The world around us is changing. Whether it's the rising sea levels or average temperature, the natural environment is consistently changing. At the same time, more and more people are living in urban areas or moving to urban areas. The global greenhouse emissions are rising. All of these changes require decision makers from both the government sectors as well as the private sector to be proactive in their planning and strategic efforts. To be able to make those critical decisions on aspects like climate resiliency, urban planning, transportation planning, smart cities, public safety, you name it, to be able to make those decisions on these critical applications, they need accurate, comprehensive, and up-to-date foundational information. Now, traditionally, creating this information has been hard, time-consuming, or costly. But thankfully, to the advancements in imaging technologies and innovative product solutions from companies like Airbus and high-precision mapping solutions from companies like Ecopia allow you today to have the information you need in a time and cost-effective manner. To talk about these things and to talk about the latest and greatest in real-world examples, we have three amazing panelists with us today. Starting with, of course, Abigail from Ecopia. Abby is the Senior Director of Channel Partnerships at Ecopia. She collaborates with a number of satellite and aerial imagery providers to grow their revenue per pixel. I'm pretty sure a lot of you already know her, so don't forget to say hi to her in the chat. She works with partners around the world to develop custom plans, technical training, and growth strategies. She's known for her innate ability to develop mutually beneficial partnerships and has led Ecopia's global partnership network today, which includes over 30 imagery partners across the world. Thank you, Abby, for joining us today. We also have Tom Harling, Head of Earth Observation Applications at Airbus Defence Space. Tom leads a team of data scientists, data analysts, and AI experts to deliver value-added products from the Airbus satellite constellation. In his role, he is keen to use EO data to give customers valuable insights and extract true value from Earth observation data. Tom has worked in this sector for over 2 decades, so he really knows what he's talking about, and he's eager to share with you the latest technologies and real-world examples on how you can use it for your benefit as well. Last but definitely not the least, we have Elodie Etty from Airbus. She's a marketing manager there for analytics and geointelligence and imagery intelligence products. Elodie has a keen interest in the use of advanced analytics to unlock insights from complex data sets, enabling businesses and organizations to make more informed decisions. So thank you, Elodie and Tom, for joining us today as well. Really happy to have you here. So it's time to kick this webinar off. So I will start with you, Elodie. If you want to give us a quick intro, please turn on your mic if you can. And let's give us a quick intro about Airbus and the importance of high-resolution imagery. Over to you now.
Thank you, Harneet. So Airbus Intelligence is part of Airbus Defence Space, and it is the largest defense and space company in Europe. So we provide over 30 years of experience and expertise to 2,000 customers all around the world. We work hand in hand with 161 resellers, and we are 2,000 employees working to solve global challenges on Earth every day. We also provide direct receiving stations, so 26 to our customers, to provide them the ability for them to directly task our satellites and receive their own imagery. So as you can see here, we have a large constellation because we believe that one size does not fit all. So we have multi-sensors, multi-resolutions, and multi-sources of data. Either you need a 30-centimeter resolution, you can go for Pleiades NEO satellite imagery, or if you need a 22-meter resolution, you can go for a GMC constellation. If you want radar imagery or optical imagery, these are all images of the airport of Nice in France. And as you can see, you can get different information according to what results you are looking for. So this shows you the link between the resolution and the swath. So you're going to be able to choose which sensor according to the final application that you have. So for example, if you want just to see a small part of the city and how many cars there are on that part of the city, you want to detect them, you can go for Pleiades Neo imagery. If you want to see through the clouds, you can go for radar imagery. If you want to see a bigger spot, a bigger area and do a change detection, you can go for a spot imagery. So according to your need, we always want to have the right product for our customers. We also wanted to make Pleiades Neo looking even better. Even though it is still amazing with 30 centimeter resolution, we process it with an HD 15 centimeter resolution. So here you have a view of the Eiffel Tower. So on the left, you can see the 30 centimeter resolution of the Eiffel Tower. And on the right, you can see the 15 centimeter resolution of the Eiffel Tower. You can see very small details. You can see some people doing some yoga around, or you can even see maybe some people selling stuff around at the bottom of the Eiffel Tower. And you could count them if you have time, of course. So, of course, accurate and up-to-date data is very important. This is an image that we provided, and we gave it to Ecopia for them to do some change detection between 2 different times. And they were able to extract information from our imagery. That is to say, they were able to say which buildings had changed or not, and which had been added or destroyed. We could do the same things with the roads or with vegetation. And this can be a big help for emergency responses. For example, which are the best roads to access to a specific area, or to assess damage or locate a specific population. So we know that you need a reliable and trustworthy provider, and you also need your data quickly and easily. So at Airbus, we provide an archive access with over 30 years of imagery. We also guarantee 1 million square kilometer at 30 centimeter resolution every single day. So according to your budget, according to your need, what resolution you need, what sensor you need, we can find a product that will correspond exactly to what you need.
Perfect. Thank you so much. So we learned, obviously, thanks to Elodie, about what Airbus has for offer today in terms of the global constellation and the fact that you have different resolutions. And thanks for showing those examples, really like the one from Eiffel Tower, for sure. Over to Abby now. So our world is constantly changing, as we've learned. Things are changing. Why are we still working on old data? Like, why are people still working with old data? And what are the challenges you've seen in your interactions with Ecopia's clients and partners about the challenges they have and how they can overcome them?
Thanks, Harneet, and thanks, Elodie. So yeah, we couldn't agree more about the importance of leveraging current imagery and the high resolution data that Airbus is creating for deriving important insights. And that's actually why 10 years ago, our founders started Ecopia, because they recognized that imagery providers like Airbus are collecting millions of kilometers of pixels of our Earth on a daily basis. But so much of that data goes underutilized due to humans' inability to process it all in a timely manner. And so, as the market currently stands, this is happening because geospatial data users have to make that continuous trade-off between affordability, accuracy, currency, and the scale of their data. So what you can do is you can access automated softwares, right? And these solutions process large areas of imagery really, really quickly and at a lower price than manual digitization. But then when you look at the results, only 60, maybe 70% of the features visible in the imagery are captured. And this accuracy gap means that you're now going to have to spend thousands of hours correcting this automated output, offsetting any time and cost savings you just achieved through automation, right? So that makes that not really a helpful tool. And then alternatively, you can go with the traditional map source, right? Manual digitization, tried and true. You're going to train these teams and you're going to get a high quality data set, but it's either going to take a really long time, making the data outdated before you even get to use it, or you're going to spend a lot of money to get this data quickly, which means you can't really do this kind of extraction at the frequency that you need it. And then on top of that, you have to account for the cost and time of creating the training materials and reserving thousands of hours to review all the data to make sure it's consistent and that the boundaries between the tiles are merged accurately. And so this trade-off of time versus cost means it hasn't really been feasible to keep maps up to date at the cadence that change happens. And I think everyone here, because we're so many people have a rich history in the geospatial industry, know that what a city looks like today is going to vary drastically in 6 months, let alone 3 to 5 years. And then let's not even talk about the stuff that's from 20 years ago, right? And so this harms the power of effective policies and the ability to track the success of strategies and replicate those when we're always using old data. And so this is where Ecopia's AI-enabled systems are just so powerful. We're extracting data at countrywide scales in record timelines while maintaining the accuracy you achieve through manual digitization. And then in addition to that, the normalized data that Ecopia's AI system outputs allows for true updating instead of map recreation, which is absolutely critical for, creating the digital twins we want or solving the problems we need to really become technologically centered and sustainability focused, right? So when we look at what this large scale extraction and data maintenance is really helpful for, I'd say first of all, it's for advancing our goals as a society. So if we take, for example, the fact that we want to achieve equitable access to healthcare, imagine spending millions of dollars on a vaccine that eradicates a common deadly illness, really hoping to improve the lives of a community, only to have half of them spoiled because the population and road information you are using misled you about a community's location, their needs, or how to access them. Or for example, we have this goal of food security. Imagine you receive a grant for tens of millions in advanced agriculture equipment to provide it to farmers, right? You give it to them, and then you realize these farmers don't actually have transportation routes to distribute the food they're growing, making the whole program look unsuccessful to donors, resulting in lost funds. And that's like a very critical application, right? And we all, these are people striving to do their best. So without accurate and up-to-date information about populations and how to access them, these super noble efforts are going to be less successful than they really should be and than we all want them to be. By mapping and maintaining a layer of all the buildings and roads of sub-Saharan Africa in partnership with the Gates Foundation, Ecopia is able to provide their organization and its affiliates with an authoritative source of information about where the populations are located and how to access them to provide these necessary resources or help them improve their communities. Historically, the information they were using was incredibly outdated, relying on census data that was over 10 years old, and many sources that they were actually referencing were actually incomplete with, as you can see here, only 20% of the roads being recorded. So RAI's ability to rapidly generate accurate vectors across 24 million kilometers squared in just under 8 months, and then maintain that data set has truly saved lives. And while it's a huge accomplishment to map such a large area in a short period, and that data itself was so valuable, what's truly incredible is how quickly and efficiently Ecopia was able to maintain the enormous data set. So back on that other slide, you saw we were doing it annually, and we updated that within, it was actually under 5 months. And so again, why this is so important is that change detections are notoriously challenging because every new capture of imagery has a new angle, which means your vectors are going to be misaligned, especially if you're looking at more than one feature and ones that have very similar properties. And as a result of this, the current best method for updating a map layer accurately was just to re-extract the layer and then compare it to the old layer. And not only is this incredibly inefficient because it requires a really large investment in time and capital to maintain these maps, it also leads to inaccuracies since manual interpretation is subjective and is changing year over year as you get new GIS engineers looking at this and looking at definitions differently. That's why Ecopia developed their 3D technology, where the AI is referencing millions of different points to accurately position the features over time, meaning that you just take that old layer, run it under the new imagery, and then just do the updates, and you're having, right, like that true updating workflow. And this AI is identifying and extracting features the same way year over year, which is also minimizing the amount of inaccurate changes flagged. And this re-extraction problem isn't just limited to huge areas like the 24 million kilometers squared of sub-Saharan Africa. The city of Detroit encountered the same problem for their 300 kilometers squared of their city. So as many communities today, just to kind of set the scene as to why this information is so important and what the city was trying to achieve, was they were facing pressure to improve their sewer systems while also redeveloping their lands to support greener infrastructure, which they would only be able to fund through the implementation of a stormwater utility fee, which a lot of cities in Europe are now implementing as well. And so to fairly assign that stormwater utility fee, Detroit needed access to up-to-date and accurate impervious surface maps, as these would inform the amount of runoff a specific property was responsible for. And then again, you'd be able to assign the exact use of public resources. And after years of procuring data manually using the heads-up approach, the city of Detroit was frustrated with how inefficient the process was, as they're always striving to work efficiently and be innovative as a government agency. Every single year, Detroit captured new imagery. Their manual digitization team would take that imagery, re-extract all the vectors, then compare it against the old data to identify any changes. And this would take them a year and a half to produce, meaning that by the time the city was accessing their new data, it was almost 2 years old. That meant fees were outdated by the time they were assigned, which leads to disputes, citizens' dissatisfaction, and of course, lost revenue, which is important for all these changes, right? Whereas Ecopia's workflow was able to not only improve the accuracy of their results, but also shorten the delivery timeframe to just 6 weeks, so their calculations were made on highly precise, near real-time information. This resulted in thousands of manual hours saved. Just get over here. And also 5.6 million in revenue for the city to maintain its green infrastructure program. And so, as you can imagine, that's a huge success again for this city. And we're currently in the process of expanding our contract for another 3 years to add 15 additional features. And again, as you can see, Ecopia's technology is completely revolutionizing what can be achieved at both the city and the country sales. So I'll hand you over to Elodie to go into more of Airbus's capabilities and why it's so complementary to Ecopia services.
Thanks, Abby, for doing my job. Elodie now, and it's interesting to learn what you talked about, the challenges GIS users and decision makers face when it comes to timing a project, the quality they need, and how Ecopia's AI is helping them scale. But as we know, input imagery is a really important criteria. So over to Elodie now to learn a little bit about Airbus's current product portfolio and the kind of markets you're serving at the moment.
Yeah, thank you, Harnit. We know that our customers need to get some imagery when and where they need it. So that's why we are committed to deliver this to our customers, and we are giving them the choice to choose which sensor they need and which kind of tasking they need as well. They need to be able to access it very easily and quickly. So we have designed an online platform that they can access anywhere in the world from internet, which is called One Atlas. And on that platform, they can also task our satellites that are connected to the cloud. So basically, we're giving our customers a joystick of our satellites so that they can get what they want, when they want, and in full autonomy, always in order to get the right information and at the right time. So this is the platform of One Atlas that you can see here on the screen, which has been designed for our customers. They get access to a living library with all the archive imagery that I've been talking about earlier, or they can task our satellites and get access to multi-resolutions and sensors abilities. For example, if you want to see Roland Garros court tonight, tonight in France, you can task our satellites just less than 1 hour before and get a picture of the quarterfinal today and of the players playing, of course. We also enable layers with a base map. So the base map, is a worldwide off-the-shelf imagery layer that is constantly refreshed. We also have digital elevation models to see the obstacles. So for example, it can be very important for pilots to have a precise view of the surface and the potential obstacles before taking an airplane. And of course, we have analytics like we've seen with Abigail at Ecopia with change detection and land use map extraction, and also object identification with identifying cars or trucks or airplanes or boats. So the idea is very simple. We want to provide the best image at the right time and with an easy access so that it enables the best decision making for our customers. So we play a key role in different sectors. Either it is defense and security, maritime, energy, agriculture, forestry with, for example, deforestation matters. land administration and mapping, infrastructures and engineering, like you will see with Tom a little bit later, with insurance and finance. So for example, for finance, we can imagine that we provide Ecopia with a great imagery of a city, and they can just see which are the new swimming pools. And for the government and taxes, it could be an important matter. So our objective all the time is to provide each market with the right data and at the right time for our partners like Ecopia to highlight the right insights and enable the best decision making for our customers.
Awesome. Thank you so much, Elodie, for that insight about the products and solutions you have available for different markets at the moment. It's interesting to see that you can task a satellite, with a 1 hour notice and look at the objects and features which the user wants. So we've seen that. Now, as we know, we have participants from over 66 countries and counting now. So thank you for all of you for joining again. And so I'm going to go back to Abby now. So, we talk about different countries, different projects, different realities. So share a little bit about our real world examples working with clients across the world and what kind of different opportunities people have available.
Awesome. Thanks, Harneet. So I think, we've spoken a lot. We've given some, case studies. And I think what next people always are wondering is like, okay, well, you're saying you're going to hit this high level of quality or you're exceeding the quality of a manual team. But, there's I think historically in the industry, there's some doubt about these capabilities. So I'll dig into why our products are created the way they are and based on the different use cases we've seen. So just to give a high level summary, from Airbus's high resolution Pleiades or Pleiades Neo imagery, so that 50, 30 centimeter, and I'll let Elodie speak more to the HD as well. Ecopia is able to extract 12 features of 3D land cover anywhere in the world. So to all those 66 countries, we've likely mapped some area within there. So Ecopia's AI is truly global. And that's for our 2D and 3D buildings, trees, parking, pavement, railways, and so forth. And it's important to note that this does come in a bundle, but you also can just select whatever features are most important to you, or you can collect them all. So let's go into the data. And the first and most important thing Ecopia is renowned for is that we're actually extracting building footprints. Right, so that's why there appears to be a misalignment here when you're looking at the roof in Argentina and the building vector. Because Ecopia is modeling the ground, the walls, and the roof of the structure, it allows us to account for, it's inevitable to have some lean in imagery and position that building where it actually meets the ground. And this is important for any kind of obstruction mapping, right? If you're a telecommunications person and you're trying to figure out where to put your networks, or you're doing logistics, right? And you need to deliver to the right spot, or you're trying to do your planning. Because it means the maximum you're going to be off of the actual location of the building is just that CE90 in the imagery. But if you extract a roof outline and that's what you're using, you could be off by 300 meters, that's like quite, anyone try sprinting 300 meters, it's quite a bit of distance. So you want that, right? You want that accurate positioning. And then, it's, again, global. So anywhere in the world, we're going to achieve that same quality we promised to you, that human level. And that's even in these less structured areas where buildings are fading into the background, you're going to get those building footprints, roads, everything's still going to be extracted accurately based on what you're seeing in that imagery. And in situations where there are partial obstructions of a feature, like here you see there's trees covering the buildings, our buildings aren't just going to stop, right? They're going to be completed, and you're going to have a really, really great estimate. It's going to be better than what even a human can do because, again, this AI is using hundreds of millions of training data sets to properly predict what that structure looks like under that obstruction. And when when you're extracting roads, you can have either polygons or road center lines. These all achieve engineering quality, which is any kind of transportation or logistics use case. It's going to hit those expectations, right? So when I say that, in addition to including vertexes, you're going to have wherever a road intersects, you're going to have vertexes. And if a road ends, right, there's going to be a vertex at the end there. And that means you're not going to have the undershoots or overshoots you might have seen from other AI systems, which is important. And then when it comes to further attribution, you also have the widths again. So if you're trying to figure out how something's going to transport through an area, you need to know how wide these areas are. And so that's attributed in the data itself. And then objects like roundabouts are going to cause no issues for our system. So when you're looking here, right, you can extract that circular shape, and you're going to have the different lanes for entering and exiting the roundabout included in there. Then when it comes to our land cover data, look at this beautiful area in L'Île-France. You're going to have, it's all contiguous, right? There's no holes in that data. So again, really, this is what you can use for engineering. If you're a government agency, this is going to match what your municipalities are used to receiving. Even NGOs, right? If you're trying to really understand that urban environment or even just natural environments, you're really going to get that granular level of detail. And for our 3D, you can see here, right? So this is quite a complex structure in Mecca with many different height components. So Ecopia is going to extract all these unique height components for you. And then to make the data useful for any kind of modeling, visualization, again, obstruction information you're trying to look at, we're going to attribute the base of the building with that CID that we're pointing. So that's the main structure. And then you're also going to have all the unique height components identified as well. Those are referenced as the PID, and those all tie back to that building base. So you know exactly where these components belong. And then we're also attributing both a relative and absolute height here. And these heights are created based on the eave because that's the most accurate way to do this. But again, if you're a telecommunications client and you're using absolute height, that's definitely something that can be adapted very simply within the algorithm. And so now that you've seen this in a 2D, right, you can take this into the 3D environment and just visualize it really, really beautifully. And it's going to look exactly like what it looks like in the real world. And so just like something more technical too, right, with this 3D data, it's all going to be topologically correct. So you're not going to have any layers going through each other or the ground, which also makes it really smooth to use. So if you're visualizing, whether it's for a game or a flight simulation, it's all going to run really smoothly for you. And when updating, we do have the capacity to provide clients with a Delta file, which identifies all the added, removed, and modified features of the specific class. And you can deliver that as its own unique file, which is what you're seeing here, right? Roads, and then all the different change categories. And so you're really visualizing those changes. Or depending on what your use case is, right, we can deliver just a collective layer. And then within the metadata of the feature, you're going to see that differentiation there. So I'll hand it over to Harneet and Tom now.
Awesome. Thank you so much, Abby. I think seeing the examples from different parts of the world was really enlightening and learning for me. So over to Tom now. So Tom, you've done some interesting projects with high resolution mapping data as well. So give us a little intro of the real projects, land use classification projects you've been taking over in the UK.
Yeah, thanks, Harneet. Just thanks for everyone for joining today to listen to this presentation. So I'm going to take you through one particular project we're working on here in the UK. So formerly called Project Lucy, so land use change identification for rail. So I guess really to start with, I'm going to take you through what we're actually doing. So after a severe derailment on the UK railway, there was a report that was produced, and this highlighted actions that should be taken to prevent such things happening in the future. So one of the points from that report was to have a better understanding of the land adjacent to or around the railway network. So taking that point from that report and that need, we are working with Network Rail and that's the sort of network infrastructure company for the railway in the UK. So we're working with them, and we're looking at how we can monitor the railway infrastructure and the land around it more effectively. So we're using a combination of high resolution or very high resolution imagery and some AI techniques to basically identify the land use 500 meters around the railway infrastructure. And then we're going to monitor this and produce some change detection every 6 months. Now, in the UK here, we have some really great OS mapping, so official mapping that already exists. And that is great, but it can only take us so far. So in this instance, we're doing some separate things to that mapping. So one, we're looking at some specific themes that don't appear in that mapping that are specific to this railway project. And also we're looking at update frequencies that are far beyond the current mapping. For this initial phase, we're looking at updates of every 6 months to this data set, but that could be improved in the future. And once we prove this concept, we could take that down to, a month, 3 months, depending on the areas and the acquisitions of that satellite imagery. So that's what we're doing and why we're doing it. So I guess really why we're using AI, why we're using these techniques, some of the techniques that Abby has talked about. And really that is for what I'd sort of call 2 key reasons for using AI and satellite imagery, really. And that's scale and repeatability. So for the particular project we're looking at here, we're looking at the UK rail network. It covers a vast area. And for this particular part of the project, we're currently only looking at 4,000 square kilometers, which is roughly 25% of that rail network. So there's a lot more for us still to cover. So that scale means that it's impractical to look at traditional methods for surveying that track. So these railways and the UK in general probably get surveyed every 3 to 5 years with aerial photography, maybe LiDAR. It depends on where you are in the country and who's doing those surveys. So really, if you're going to find out about change, as Abby mentioned earlier in her case studies, that you need to find out about that change now, and you need to be alerted about it now. So a survey 3 to 5 years in repetition doesn't really cut it for what we're trying to do. Also, those surveys can take a number of years to conduct. It's a large country, a large network, so that data isn't all collected within a very short time frame. So what we're doing here is we're using satellite imagery. We can acquire this a lot more frequently, and the number of satellites that Airbus has in its constellation means that we can acquire this in relatively short time frames. The other thing to note about this, sort of the scale of this data and the repeatability, is why we're using AI techniques, and that's because it's a large area. It would take probably many man-years to map this individually, and we want to do this every 6 months or so. So we need tools that can do this regularly, so we can repeat it and on a large scale. And that's why we're using AI techniques and using our own technology and Ecopia technology to make this data set. So I'll go on to show you some of the results of what we're doing. So this just shows some of our early results on what we're trying to produce. So we're using a combination of Ecopia, roads, and building outlines. And as Abby has previously said, the accuracy and the update of those is excellent, and so that's why we're using that technology there. We're then using our own AI techniques, machine learning and deep learning, to enhance our VHR data and also of the data sets to produce the general land use. So we're using not just RGB optical imagery, we're using other data sets. So we include some of the sentinel data, which have extra channels to map different features, and we're using also radar data. I see in the chat that people have mentioned cloud cover over certain places, and one of the techniques we use and one of the data sets we use is what we call SAR, so radar imagery, and that can see through the clouds. So we're also using those techniques for some of the data set where we are looking at flooding. In the UK, flooding tends to come from cloudy conditions, and so radar imagery is one of the few data sets that we can use to monitor that. So just to look in a bit more detail, this is the kind of data set that we are producing. These are early samples of that data set, and we'll be rolling this out to Network Rail shortly. We plan to hopefully expand this into the whole network, and then potentially other European networks and other networks around the world as we develop the tools that we are using. So this just shows how we're categorizing this land use, and then what we do is we do this once, and then we do recapture the basically the same AOI with different imagery. In this case, it's 6 months later, and we perform that process again, and we do some change detection, and then we deliver this all via a GIS API to the customer, so they can interrogate and investigate this. And this hopefully feeds into their risk tools and the tools that they use for inspections of the lines and the tracks. And this is basically all to improve the safety of the railways, so that the people can pick up changes to land use earlier, and can then investigate that and hopefully prevent those disasters and accidents that can happen. So as I said, we are using the Ecopia buildings, and it is a really good data set. And we also then receive that change layer from Ecopia. So this just shows that these are our 2 epochs of data, 6 months in between. As you can see, we have a lot more buildings. Now, for our product, more buildings, more roads, I'm only showing the buildings here, but means more hard surface, more runoff, potentially drainage issues. So these are the kind of things that we're trying to highlight with this data set, so that people can basically look at this data and say, okay, changes have been made, this has affected something, what can we do about this? So it's really about giving the customer the answers from all this complicated data. There's a lot of data, it's very complicated. What do we do with it? We say, okay, we analyze it, we use AI techniques, we use Ecopia data, we put that together and say, okay, this is where you need to look, this is what you need to do. And that's effectively a large part of what we do. So that's it from me. I will now hand back to Harneet.
Thank you so much, Tom. That was great. Really interesting to learn about this kind of land use classification for railway. So moving on. So we've had a lot of information shared between all the panelists. So thank you again for your time today. And now I'm going to go back and starting with Elodie now. So a lot of information shared, lots about AI, lots about high resolution imagery and different applications around the world. If you have to summarize and give some key takeaways from Airbus's side, what would you say?
Thank you, Harneet. So at Airbus, we believe that we need to stay updated with technology and evolution, and we help our customers to stay in this mood of looking forward to our technology. So that's why we provide training, for example, and we foster partnerships and collaboration, for example, with you. At Ecopia, we provide the highest data quality possible, and we foster innovation and creativity by supporting any initiatives. So you got it about Airbus. We provide the images you need, where and when you need them, to get valuable insights and tackle any challenges all around the world. We have our Pleiad Neo satellites covering the entire globe, even at extreme latitudes. So every day there is a Pleiad Neo flying over your head. So you can think about this tomorrow when you wake up. And here you have a picture of the Festival de Cannes. And if you look at the top right of the picture on the beach, you can imagine it is Leonardo DiCaprio walking with his girlfriend and having a glass of champagne, for example. Or you can imagine like they're smiling. And yes, I think it's amazing what we are able to do nowadays with technology and satellites.
That's amazing. Awesome. Over to Abby. Abby, what would you be sharing in terms of key takeaways for our clients when it comes to AI-powered mapping?
I don't know if I'm as up to date with my pop culture references as Elodie is, but I think I'll go. I want to reinforce kind of your message, Harneet, that you said at the beginning, where just, our world is changing at a faster pace than ever before. And our foundational maps like we just can't sacrifice on those anymore. They need to reflect these changes if we want to make our countries more resilient. We want to improve access to infrastructure and basic goods. And, we want to implement the technologies that are going to help us achieve these things. So in partnership with Airbus's advanced imagery capabilities, Ecopia's AI-enabled system, and sorry, I forgot to change over to our slide here, but we're going to afford users access to scalable and repeatable large-scale map creation that's going to achieve the high quality necessary for such high-impact initiatives. And so that's really, if we're going to take anything from the Ecopia side, I think that's kind of the last message I'd like to leave everyone with.
Very simple, well, simple to understand, but really valuable, especially in the times we live in. So, Tom, any last comments or suggestions, tips, or tricks for people using this kind of data or looking to use this kind of data?
Yeah, I mean, I think that the real the key takeaway for me is, I guess we are separate companies in that Airbus have a lot of imagery and Ecopia have the techniques to extract the data. But I think it's a key sort of relationship because there is just so much data out there. And as been mentioned through this presentation, we can't possibly look at it all. So, the amount of data that we capture with a Pleiades NEO satellite, one person could spend probably a year looking at the data that we capture in a day. So we need to be able to basically harness all this data, and using these advanced techniques that Ecopia are developing, that enables us to give those answers to people from that data. And I think that's the real key takeaway, is analyzing this data and making the most of this data.
Sounds great. Thank you. So guys, stay tuned. We're moving on to the Q&A round. There's been a bunch of interesting questions that have come in already. Time permitting, we'll take as many as we can. Feel free to ask your questions in the Q&A tab. And if you're also want to ask the same question, you can upvote a question and we can take that on. So I'm going to start rapid firing these questions to the panelists today. Start with LD first. The question from Robin is about what is HD15? If you can explain a bit more, please.
Yeah, sure. So hi, Robin. The HD15 is the image collected with our 30 centimeter special resolution Pleiades NEO satellites. And so we process this image with an algorithm to enhance the level of details and with the same geolocation accuracy. So the details are sharper, the colors are brighter, and in order to obtain better looking visuals.
Sounds great. Over to Abby now. Abby, Jessica Kelly is asking, what is Ecopia's ability to train AI to capture new types of features?
Yeah, I think the way I would have you think about this is that, our AI is really competent in looking at imagery and trying to do what the eye does. But because you're setting up a rule set, right, you have to think about, okay, what is the feature? So we need to have a very strong definition around it, right? So you can't, it's just like, oh, it's this one random color. So we want to make sure there's definition, and then we want to make sure, and we want to define how it's distinct from other features. So the short of it is that yes, our AI is incredibly adaptable. And then what we would love to work with you on is how we can really define that so we can get those accuracy levels up to the 95 plus that we are used to committing. And so we're happy to walk that through with you. But really, my guidance to you would be like, look at an image. Can I distinguish that from all these other features within here? And then the answer will likely be that if you can do that, then yes, we can automate it.
Sounds great. I'm going to go back to Elodie for this one and come back to Tom for the next question. So Elodie, question for you. Aditya is asking, is it possible for private companies to procure 1 to 5 square kilometer task optical data rather than the standard 25 square kilometer of the AOI?
Yes, sure. There is a possibility to order small areas of interest with an archive subscription at Airbus. And for tasking, we only propose a pay per order option with a minimum of 100 square kilometers for tasking our Pleiades NEO 30 centimeters resolution or our Pleiades 50 centimeter resolution.
Awesome. Tom, a quick one for you. Srinivas is asking, which GSD satellite images are you using for this real land cover mapping?
Currently, just because of availability, it's 50 centimeter. So in Airbus terms, that's the Pleiades satellite. If we had done this, started this project now, we would try to use the Pleiades NEO 30 centimeter, just because it gives that extra sharpness and that extra resolution to detect objects.
Awesome. I'm going to go back to Elodie for two quick questions if you can answer. One is about, do you work with, German is asking, do you work with resellers because you cannot work with startups? And the next question is it really possible to task the satellite data acquisition with 1 hour notice?
Yes, of course, for the resellers and startups, you can just contact us and we will be happy to talk with you and see how we can provide imagery to you. And for the 1 hour notice, yes, our latest constellation with Pleiad Neo can be tasked 30 to 40 minutes before the acquisition of the image.
Awesome. Abby, quick one for you. This is a question from Ahmed from Kuwait. He's asking, for using Ecopia services, do we have to purchase the imagery on our own from Airbus, or would it be possible to have everything that is the imagery and the extraction from Ecopia?
Yeah, I think the Airbus team has shown themselves to be very flexible. So really, like, as we want to offer you solutions that make sense. So they'll work with you if, they got the archive, we can work to deliver vectors. If you need the imagery, they'll sell that to you too. So it's really, I think the Airbus team's really there to help, and they'll do what's best for your solution. So you can definitely, I'm sure they're happy to discuss your needs and figure out what's just going to make the most sense.
Okay, next question, I would say, Elodie, Tom, feel free to pitch in for this one. Venugopala is asking, we are working for an energy pipeline right of use monitoring on daily basis for encroachments. Can Airbus meet the daily high resolution imagery requirements?
Yes, I would say that we will need to have to study the request for daily monitoring. So we really invite you to contact us, and we will be happy to help you.
Perfect. This one, Abby, you can take, please. As again from Aditya. He's from a coastal city in India where they have cloud-covered optical images for more than 6 months. How does Ecopia deliver the latest information on the ground infrastructure?
So again, I think we're not promising to do things that are impossible, right? So if you have cloud imagery, you cannot see under a cloud. Your eye can't, the human can't, it doesn't matter who it is. So that's not going to be feasible to extract under. But the good news is that the team at Airbus is really great at tracking all these weather instances, and they have years, decades of history, right, doing this. So they're going to work with you to be able to get that image as frequently as possible. Unfortunately, none of us can circumvent the weather, but we'll be able to. I think you'll be in really great hands to help you find a way around that, so that we can extract that information as as the imagery becomes accessible.
At the end of this session, we'll have the contact information for our panelists today, and obviously you can visit the websites. Feel free to get in touch for more information. I'm going to go over to Abby back again for a quick question from Brian. He's asking, does Ecopia provide any analysis about the vector data, such as area calculation or something else?
Yeah, you can definitely, we can explore those different needs. Areas, definitely one that we can include. 3D, you can add the volume. We had mentioned the width, so please feel free with your specific attributes. Again, it's really just what are you seeing is kind of the key driver for just the optical imagery-based data.
Okay. Question from Clement. Thanks for, I'm not sure who's this for, but thanks for the presentation. Just one question. When detecting high buildings, how do you manage the shift induced by the satellite angles? I think that's questions for the Airbus friends here. How do you manage the shift induced by the satellite angles?
I can jump in from the building detecting side, right? So I think it's inevitable to have some lean in imagery, but that's the power of us working together, is that, again, our AI is modeling the ground, the walls, and the roof. And so then you will position that vector where it's actually meeting the ground instead of the outline. And so you're going to still have a very simple answer, right? Is that building footprint? So where it's truly meeting the ground. So that's, I think, for any kind of analytics you want to do on top of the imagery, that's going to be possible. And then I don't know if Elodie or Tom want to jump in with anything imagery specific I might have missed.
No, I think that captures it pretty much. As long as you've got a good ortho, then I think you should be good.
Awesome. There's a question from Dr. Ali for Elodie. What is the native resolution of the 15 centimeter imagery? Stop. Is that already right? Yeah. Can you hear me? Yeah. Okay, I'm gonna go to Abby quickly for this one. Does Ecopia Solutions work with SAR, S-A-R?
So we do not extract off of SAR data. The reason being that color is one of the key differentiators for a lot of these different features. And obviously you don't have that in a SAR image, right? It's just mono colored, but some of these different sources can be used to enhance enhance the accuracy of the features post extraction. So if we're just going to talk about like specific water bodies, you can do it from the imagery, but sometimes infrared's really helpful, so you could run that underneath afterwards. But when it comes to actual vector extraction, that's optical imagery based.
Okay. We have some other questions, but I'm going to be respectful of the time. There's one last question I'm going to go back to, which I asked from Dr. Ali Al-Masri for Elodie. What is the native resolution of the 15 centimeter imagery?
Yeah, sorry. So for the 15 centimeter question, we extract a 30 centimeter GSD Pleiad-Neo image.
Perfect. Thank you. I know there have been a lot of rapid fire questions coming in. So we have more questions to go, but I don't think we have the time left for that. But what I'll do is we'll make sure that we reach out to everyone who asked a question independently of this webinar as well to make sure that we answer your question. And thank you again, everybody, for joining today. This been a really insightful webinar for me, and I hope it was a good use of your time as well. Thank you again to our panelists for joining us today. Thank you, Abby. Thanks, Tom and Elodie, for today. Your contact information is up on the screen.
Thank you, everyone, for joining us. Yeah, please feel free to reach out, and we would appreciate all your feedback on what you'd like to hear more of, what you'd like to hear less of, and we appreciate you sharing your time with us.
Yeah, thank you so much.
Yep. Thanks, everyone.